Okay, today also we'll see the some basics. Okay, completely subject introduction. My subject is here the digital system design using a Verilog. It's an optional subject. It's an optional subject. Okay, subject code is here the BEC 654A. Okay, there are two types of optional subjects. One is the departmental subject, another one is the out of the box. Means what? Very department subject irutta. Irutta very department subject. Okay, this is the completely the electron subject. Okay, this is what the electron subject. Electron subject. Okay, we have the subject name is here the DSDV means what the digital system design using Verilog. Okay, digital system design using a Verilog. As you all know the what is the digital system. In the previous semester, the DDCO subject we have learned. Okay, what type of digital systems we are designing there. Okay, there are two types of digital systems. One is the combinational digital systems. Another one is the sequential logic circuits. We have learned these things in the previous semester, third semester. Okay, the same basics we are using the for the building the completely the digital system design using Verilog. Okay, as you all know the communication purpose, in order to communicate with the other person we need the language. Okay, in the similarly the computer also have the so many different types of languages like Fortran, COBOL and different types of languages we are using in order to communicate with the processor. Similarly, in order to express the digital system, in order to describe our digital system, it means what the here the whatever the digital systems designed using the hardware components, electronics hardware components. These to be described, these to be expressed in the one language called as the hardware descriptive language. Hardware descriptive language HDL. Hardware descriptive language. Inbuilt, it is using the Verilog code. Inbuilt, it is using the one type of code that we call as the Verilog. That's what the name is. What the basic classes in the last previous semester. That's the pi equals to AB plus BC. This is the one of the equation we learned in the third semester DDCO subject. ಅದು ಆಮೇಲೆ ಮಾಡಬೇಕು ನಾನು ಎದುರದಾಗ ಮಾಡ್ಬೇಕಾ okay VHDL Verilog hardware descriptive language. It's one of the easiest subject compared to the DDCO. Here we'll be using the Verilog code. Okay, you know how to describe, how to write a code for this Boolean expression. Okay, we'll see that one. First one is to be, this is the what the real world problem. It is implemented in the form of what the Boolean equation y equals to AB plus of BC. As you all know the basics about the how I got this equation in the previous DDCO lab. There I designed this equation. So with this we can design the hardware with the help of the this. We need the two AND gates, one OR gate. This is what the AND operator I need, one OR operator I need here, OR gate I need, so that it's to be expressed this mean term, to be expressed with the help of what the AND gate A, B. This is what the W. Okay, this is what the B and this C. Okay, the B is very common here between these two terms, so that I am taking the interconnection between these two, so that this is what the Y output. Because of the plus operator I am using the OR gate. AND operation purpose AND gate I used, plus operation purpose I used the OR gate here. so that the output is the only one that we call as the Y. The inputs are how many? 3 are there, A, B, C. 3 are there, A, B, C. Though, so that the output of first AND gate is what we call as the W1 and W2. These are the inputs, this is the output. What is the in between these two gates? We call this what the interconnection. This we call as what the wire. This we call as what the interconnections or wire. So that we are defining their names as the W1 and W2. These are the interconnection. But the output of the first AND gate, second AND gate. We designed the digital system with the help of while referring this Boolean equation. So that it is to be expressed. This is our hardware design. Whatever we are looking here, the two AND gates are one OR gate is there, inputs are there, only one output is there, and also input interconnections are there, one output in between the wires. In between the two gates or with whatever connection we have, that one we call as what the wires. ಇದಕ್ಕೆ ನಾವು ಇನ್ಪುಟ್ ಅನ್ಬೋದು, ಇದಕ್ಕೆ ನಾವು ಔಟ್ಪುಟ್ ಅನ್ಬೋದು. ಇದು ಇನ್ಪುಟ್ ಆಗುತ್ತಾ, ಇನ್ ಔಟ್ಪುಟ್ ಆಗುತ್ತೆ. But it's the connection between the two gates we call as the interconnections or wires. We can express the wire is nothing but the interconnection between these two. Input ಅನ್ಬೋದು, ಈ ಕಡೆ ಔಟ್ಪುಟ್ ಅನ್ಬೋದು. But ಇದಕ್ಕೆ interconnections ಅಂತೀವಿ, wire ಅಂತೀವಿ ಅಷ್ಟೇ. So that we know how to design a digital system from these Boolean gates, derived gates, and also special logic gates also. Derived gates, basic gates are what the AND gate, OR gate, and NOT gate. Similarly, the derived gates are what the NOR gate and the NAND gate, XOR gate, XNOR gate. Special gates are what the NAND and NOR gate. But we will be using the every time in order to implement these gates, basic digital system, only the basic gates. And also sometimes if it is necessary to have the only one type of gates, then definitely we will go with the special type of gates that we call the NAND gates or NOR gates in order to have the one special design. So how can I design? Okay, I got the design from the Boolean equation, so that I have to write the some program related to this one. This is with this we can write the program with the help of the HDL hardware descriptive language in three ways. One is called the structural model. The second one is the data flow model. Third one is what the behavioral model. Okay, first we'll see how to write the structural model. Okay, structural model means what we consider the one model. We can name any name, it's a struct, and the inputs are what are those outputs here? The Y input are what the ABC. You have to put the semicolon, and also inputs are what are those? A comma B comma C. Output are what are those? Y is the only output. Wire I have to define the wires also here. Wire, not the wires. Wire W1 comma W2, and the end of the module. It's the skeleton for the writing of the program. Okay, HDL program for this purpose. Okay, this is the module and end module. In between this one only we will be writing the logic here. What type of model I am writing here? Three ways are there. One we can say the structural model. Another one is the data flow model. Third one is what the behavioral model. I consider here the structural model. So that structural, what are the looking here, the what type of design here? This is what the hardware design. Here I use the two AND gates. Only one OR gate is there. And G1, the output is what the W1. Output of the first AND gate is what the W1. So that I have to write the W1 comma A comma B inputs. Okay, first I have to write the gate name as the keyword and also it's to be named with the G1 also. Even you can always bury the ready to the, but the first input, the output is the first we should write W1 A comma B inputs. Okay, semicolon. Second AND gate is here. Second AND gate is also there, G2, and the output of the G2 is what the W2 is there, W2 B comma C is there. One more thing I left here, the second, third. Which one is the, what is this? What is this one? Huh? What is this gate? OR gate. So that I have to use the R G3. Output of this OR gate is what? The Y. Inputs for this AND OR gate is what were those? W1 comma W2. This is what we are expecting the, and also written the program in the structural model completely. The same output we can also get from the other type of writing the program. That one we call as the data flow model. We'll write that one also. Model. The model name can be anything. Okay, you can write any name. Your you can also write the your name also. Y comma A comma B comma C. Okay, inputs are what are those? Input ಬರಿಬಾರ್ದು, inputs ಅಂತ ಬರಿಬಾರ್ದು, input ಅಂತ ಅಷ್ಟೇ. A comma B comma C. Outputs ಅಂತ ಬರಿಬೇಕಾ, output ಅಂತ ಬರಿಬೇಕಾ, output. Wires also we should define wire W1 comma W2 and the end model. Here we are writing what we are trying to write, the same the logic but the different ways. The same output should get the expressing of the logic design with the different logic here. What type of logic we are using? Data flow model. For the data flow model, we will be using the one keyword that we call as the assign keyword. Assign. The gate name is here. The what is the output of the first AND gate? W1. Assign W1 equals to A AND gate. AND gate for the inputs for the AND gate is that A comma B. A comma B. The first AND gate to be written as the ambassador. You will be using the ambassador. Second is the what? The assign W2 B ambassador of C, and third is what? The same as the assign Y equals to W1 R with the W2. R with the W2. This is what the writing the program in the data flow model. Atik. Or what we are doing, writing the program, same output will get to the in the data flow model also. Similarly, I can also write the same with the in the behavioral model also. Same logic will same concept will be writing, but the different way. Model, behavioral, okay, same as the Y comma A comma B comma C. Same as the input A comma B comma C, output Y. Wires also we should define W1 comma W2, end module. Here the we'll be using the only two keywords, that's the register keyword. Another one is what? The always at the rate. Register keyword is register keyword is used to write the Y output, and the always keyword is used to write the inputs A comma B comma C. You should not write the any semicolon here. Pujappa. Okay, then write the some logic behind in between this one. Y equals to A ambassador of B, B ambassador of C. This is what the R we are writing with the straight line. Straight line. Whatever we written the programs in three ways, the same output we are getting, but the different approach. What is the necessity of writing the three ways? It means what? If you are getting any complexity, if it is a easy digital design system, your digital system is very easy. If it is not containing any complexity, then definitely we will write the program in the what? The data flow or structural model. Similarly, if you are getting any complexity in the digital system, we'll go with what the data flow model. If you have the more complex, the earlier one, definitely will write the program in the behavioral model. It means what is the necessity of writing the program in 3 ways means what? If you are getting any more complexity in the our digital system, definitely will go with the different approaches. These 3 types only we are getting the basics to what the DSDV, digital design system using the Verilog. Our digital system is what the design is what the y equals to AB plus of BC. This is to be written in the expressed in the language HDL in the 3 ways, 3 approaches. One is the structural model, second one is the data flow model, third one is the behavioral model. Okay, if my digital system is very easy, then definitely I will be designed to express the language in the model programming, that's the structural model. If it is more complex, then we'll go with the data flow model. If it is a more and more complex, then definitely I'll go with the behavioral model. If you know these basics, okay, definitely I can build okay DSDV with a very easy way. In the digital system design with the Verilog is the we have the 5 modules here also. For this one, I have the 2 reference books here. One is called the Verilog HDL. This is the old book. This is in the 99% syllabus is in this book only. 100% not the 99%. 1% is from this book. Actually I seen complete syllabus in this. 99% of the syllabus is from this book only. Okay, complete each and every bits. And also only 1%, that is the 5th model, is from this book. Only 2 to 3 concepts from this book. Okay, not necessary to have. You can also get the some other photocopies from this book. Okay, definitely you should have this book along with you. I have the 99% of the syllabus from this book only. Okay. Okay, this one we consist of the 100 marks for the SWA and the CI. It is to be 50 marks and the 50 marks. Okay, continuous internal evaluation should have the 20 marks each. 3 tests here. You should have to write the 3 internal tests. ಎರಡಿಲ್ಲ 3 ಬರೆಯೋ ಕಂಪಲ್ಸರಿ. 3 ಇಂಟರ್ನಲ್ ಟೆಸ್ಟ್ ಇರ್ತಾವ. ಭೂಮಿಕಾ ಎಷ್ಟಿರ್ತಾವ? 3 ಇಂಟರ್ನಲ್ ಟೆಸ್ಟ್ ಇರ್ತಾವ. Okay, each will carry the 20 marks. 60 divided by 3 is what the 20 marks. Okay, I have to give the 50 marks. No, we don't have the any lab here. We don't have the internal integrated lab, even the any external lab also. I have to give the 30 marks. We have to divide this 30 marks to what the 20 marks for the seminar. Seminar is compulsory for you all, so that there is no excuse, and also there will be no escape also. ನಾನು ಬರ್ತೀನಿ, ಯಾರು ಇಲ್ಲ ಬರ್ತೀನಿ, ಬಂದಿಲ್ಲ ಅವನದೇ ಕ್ಲಾಸ್ ಬರ್ಬೇಕು ಗೊತ್ತಾ. ಬೇಸಿಕ್ ಬೇಸಿಕ್ ಏನು ಮಾಡ್ತೀನಿ ಹೋಗೋದು ಸುಮ್ಮನೆ ಖಾಲಿ ಕೂತ್ರಿ ಮೀಟಿಂಗ್ ಮಾಡಿ. Okay, 3 internal tests are there. One is what the 3. Okay, 3 internal tests are there. Divided by 3. Compulsory you should have to write the 3 internal tests. Okay, and also 20 marks for the seminar. I'll be teaching the first module, second module, and the fifth module also. But definitely you should give the seminar on the third and the fourth module. Okay, and the 10 marks are there. One more 10 marks. I'll be conducting the GD, Sneha. Okay, I'll be conducting the GD group discussion. I'll make the groups. Okay, here. Definitely this will be helpful for us to build the your okay, definitely these type of activities I need for the 7th semester, so that I am taking these type of activities instead of taking the PIJ or GD. Just I am taking concentrating on the seminar topics. Okay, and also we have the in this also we have the 5 modules. First module is to be about the completely basics of the HDL. Basics of the HDL. Hardware descriptive language. Completely basics of the HDL. Second one is what the second module is the. It's completely the data types. What type of get data types? Variables. Some other whatever the need for the writing of the program. Third one is what the. It's the data flow model. It's completely data flow model. Writing a program in the data flow model. And also fourth model, behavioral modeling. Fifth one is what the fifth one is the gate level modeling or structural model. Okay, I will be teaching the in detail about the module 1, that's the basics of the HDL and evaluation of the HDL, and also a flow chart. Okay, one design flow is there for the, as you all studied in the waterfall model, spiral model, V2V forward model. These things we have studied in the, you all studied in the basics. So in the what the type. The similarly here also I have the one data flow is there. Flow of flow chart is there. How to design a ICs. It's a completely the step-by-step procedure for the designing of the ICs, integrated circuits, and also some trends in the HDL solid alls we will be seeing, and also bottom-up approach, top-down approach. So many things are there. Okay, in this first module, it's only one the thing is there. It's the 20 marks. Each will be having the 2 questions are one first and second question, 20 marks. You have to write the only one question. Okay, here the first question is the what the compulsory question is there, data flow model. Okay, that's the, it's the only one that's the IC designing of the IC in the processor. It's the compulsory question. Each and every examination they asked this question compulsory. 10 marks is fixed. ಇನ್ನ 25 marks ತೆಗೆ ದೊಡ್ಡ ಮಾತಲ್ಲ. 10 marks ಅಂತ ಫಿಕ್ಸ್ ಅದ. ಯಾವುದು ಕೇಳಲಿಕ್ಕೂ ಇದು ಕ್ವಶನ್ ಅವರು ಕೇಳ್ತಾನೆ. ರೈಟ್ ಎ flow chart or step-by-step procedure for the integration of ICs in designing. This is the sample compulsory question. Here also we have the one more question is there. That's also 20 same. Okay, 100% 50 marks are very easy. But thing is that remaining are 50 are the you have to read and write. Okay, first one we will consider take the first module, that is the module 1. Here also we have the two chapters. One is the what the overview of the digital designs with the Verilog. Write down this one, overview of the digital design with the Verilog HDL. Second one is the emergence of evolution of CAD design, computer aided digital design. Third one is emergence of HDL. Typical design flow. Okay, this is the very important. Typical design flow is there, no? This is the fixed question. Here we have the, this one is the fixed question. 100% they will ask in the examination for the 10 marks. And also we have the importance of HDL. Shukumari, come and stand here. Come here. Come here. Come here. Popularity of Verilog HDL. Note down this one. Trends in the HDL. Trends in HDL. Write down this one. Write it. Write it. ಬರ್ಕೋ ಸುಮ್ಮನೆ ಅದೇ ಹೇಳಿದೆ ಏ ನಾನೇನು ಮಾಡೋದು ಕ್ಲಾಸ್ ಇರಲ್ಲ ಕ್ಲಾಸಿಗೆ ಹಿಂಗೆ ನನ್ನ ಕ್ಲಾಸ್ ಇವಾಗ ಹೇಳು ಅದಾ ಹಿಂಗೆ ಅಂತ ಬರ್ಕೋ ಅದು ಮದುವೆ ಬರ್ಕೊಂಡಿ ಯಾವಾಗ Okay, first one is the overview of the digital design system with the Verilog. Here we have the 4 questions are there. Among these 4 questions they will be asking in the first question is the in the examination. First question is from these 4 questions only. This is the very important typical design flow. This is what the importance of the HDL and also trends in the HDL. These 3 are the very important. These are the repeated questions. Okay, FAQs, frequently asked questions from these topics only. These 3 topics, from these 3 topics they will be asking the 20 marks. ಬರ್ಕೊಂಡ್ರಿ ಶುಕ್ಮರಿ ಬರ್ಕೊಂಡ್ರಿ ಕಾಣಿಸ್ತದ ಮತ್ತೆ ಇಲ್ಲಿ ಕೂತ್ರೆ ಆತ ಕಟ್ಕೊಡ್ಬೇಕು ಇಂಪಾರ್ಟೆನ್ಸ್ ಆಫ್ HDL ಬರ್ಕೋ ಟ್ರೆಂಡ್ಸ್ ಇನ್ HDL ಟ್ರೆಂಡ್ಸ್ ಇನ್ HDL ಯಾಕೆ Okay, first one will consider the evolution of the computer aided design, digital design using the over the 25 years, 1980s, the over the 25 years back, the 1980s, the digital system designs are usually implemented with the help of what the vacuum tubes and what the okay, over the 25 years back, the digital system designs usually implemented with the help of the transistors and the vacuum tubes. These to be implemented with the help in the on the ICs, okay, integrated circuits. There are the four types of ICs are there. One is what the SSI, another LSI, third one is what the MSI, fourth one is what the VLSI. SSI is nothing but the small scale integrated circuits. Small scale integrated circuits. Small scale integrated circuits. These to be less than the hundreds. Okay, less than the 100 types, 100 designs. Okay, less than the hundreds. Less than the 100 transistors are will be using. Okay, these to be designed. These to be ICs to be designed with the help of the less than the 100 transistors or vacuum tubes here. Okay, and also will be have the LSI. LSI is nothing but the large scale integrated circuits. Okay, these type of ICs are implemented with the help of the over the more than hundreds of transistors, and also will be having the medium scale integrated circuits. Here the more than thousand transistors will be used to implement the digital design systems. If I have the more complexity in the my digital design, definitely I will go with the this type of ICs. Okay, VLSI is nothing but the very large scale integrated circuits. Here the millions of or millions are millions or billions of transistors are used to implement this type of circuit ICs. Okay, what these are the different types of ICs. If my digital design system is for the very simple, it's not the we don't have any complexity. Definitely, I'll go with what the SSI. This means what the small scale integrated circuits. Definitely, the nowadays we are using the VLSI types of very large scale integrated circuits type of ICs nowadays, because nowadays our digital design systems are using the very complex digital design systems we are using, so that the ICs will be built based on what the very large scale integrated circuits. Okay, very large scale integrated circuit. Anyhow we are designed our digital design system with the help of the transistors, and also we need to check this one. We need to check whether it is working properly or not. This one will be done with the one type of electronics device that we call the EDA tool. It's nothing but the electronic design automation tool. This is the testing tool. Okay, this is what the testing tool. This will check the only the hardware components. whether my IC is working properly or not. It will check. If my IC is there, that's to be what the for the OR gate purpose. If it's my IC is for the AND gate purpose, I have to check whether this IC is working properly or not. This will be done with for the EDA tool. That's what we call the electronic digital automation tool. This will check whether my IC is working properly or not. This one is available already available in the this type of tools already available in the electronics department. Okay, they will check whether this IC is working properly or not. They will insert the ICs in the tool. They will check whether it is working properly or not. Okay, whether it is working properly or not. This one to be done with the help of what the one tool that we call the electronic design automation tool, EDA tool. Okay, EDA tool is there. Okay, anyhow we are testing the hardware components, and also we designed the our digital system design using the Verilog code, and also we designed with the help of the ICs, and also we check the whether the ICs are working properly or not. I have to check whether this IC is working with the help of what the type of software side. I have done with what the hardware component. I have to check whether my software is working properly or not. This is to be done with the writing the program and also writing a inputs for the inputs combination for this one. How to write send the out input combination with the help of what the test bench. Test bench is the one of the programming. This was the consist of only the input combinations. For example, if I consider with the AND gate, how to write the what is the inputs for the AND gate? A comma B, and the Y is the output. Now the input for the OR gate is what the A comma B, Y, and the output for the NOT gate is what the here. What are the inputs? How many inputs for the NOT gate? How many inputs for the NOT gate? With A, B, and C. Na? How many inputs for the NOT gate? Bhumika. How many inputs for the NOT gate? Ishwari, ido. Shukumari. How many inputs for the NOT gate? How many inputs? We have the only one input, that's what the A bar. B is the B bar. Importing, that's what the inverted getting. We are getting the input combination. Okay, for the input combination A comma B and the Y. For the AND gate operations 0 0 0 1 1 0 1 1. The real world entity, each and every entity will have the two results. One is called the true or false. 1 or 0. True or false, or 1 or 0 input combination we are. So that we have the two input combinations, that's the A, B. A and B are the two inputs are there. 2 raised to 2, how many input combination we will get? The 4 input combinations. 2 raised to the power of 2, how many? 4. 0 0 0 1 1 0 1 1. So that I have to perform the operation here the by A dot B. It's nothing but the dot operator is there. 0 0 multiply 0 0 1 1 0 1 1 1. This type of input combinations I have to give, and the whether I have to check the whether it is working the AND gate properly or not. This is to be done with the help of what the one type of code in the combination we are sending through what the test bench. Whether it is working properly or not, we'll check with the help of the simulator that we call the simulation of the simulator. It will generate whether it is working properly or not. We know the how to design the ICs, and the after the designing the ICs also we'll check the whether IC is working properly or not with the help of the one tool that we call the EDA, and the whether this IC is working according to the my requirement software requirements with the help of what the input combinations throughout the test bench simulation. We call it the simulation. This is what we call as the evolutionary of the evolution of our HDL tool. HDL means hardware descriptive language. How ತರ develop ಆಯ್ತು, ಎಲ್ಲಿಂದ develop ಆಯ್ತು, ಹೆಂಗ್ ಆಯ್ತು ಅಂತ this one. Now we'll switch on to the this is all about the first topic, that's the what the evolution of the CAD tool. That's nothing but the computer aided design, digital design. Charger alle bag na I think Okay, we'll see the next topic in the next class. Don't worry. Copy this one, whatever I written on the board, just to copy that one. You know, Atta. ಸುಮ್ ಕೊಡ್ಬೇಕಾಗ್ತಂಗೆ ಈಗ ನಿನ್ನ ಹೆಸರು ಗೊತ್ತು ನನಗೆ, ಇಕ್ಕಿನ ಹೆಸರು ಗೊತ್ತಿಲ್ಲ, ಇಕ್ಕಿನ ಹೆಸರು ಪೂರ ಗೊತ್ತಿಲ್ಲ. ಇಕ್ಕಿನ ಹೆಸರ ಇಕ್ಕಿ ಭೂಮಿಕಾ, ಇಕ್ಕಿ ಭೂಮಿಕಾನು ಸುಪ್ರಿ ಭೂಮಿಕ ಯಾರು ಆಕಿ ಇನ್ನೊಬ್ಬೇಕಾನು ತಾರಲೆ. Hey, definitely I'll give the completely syllabus. Okay, even the ಬ್ಯಾಗ್ ಅದ್ರ ಮೇಡಮ್, ಬ್ಯಾಗ್ ಅದ ಕೊಡ್ತೀನಿ ತಾಳ್ರಿ, ಒಂದು ನಿಮಿಷ ಇಲ್ಲೇ ನಿಂತ್ರ ಬಂದು. ರಿವಲ್ಯೂಷನ್ ಇದಂತೆ ಹಾಕ್ರಿ, ಯಾರು ರಿವಲ್ಯೂಷನ್ ಹಾಕೋರು. Okay, today I'll be sending the syllabus copy, even the I'll be sending the old question papers, okay, previous year question papers also, and even I'll be sending the some soft copies are there. Notes, okay, I'll be sending that one also. Don't worry, I'll be giving the 100% solution for your subject. ಯಾವುದೇ ರೀತಿ ವರಿ ಮಾಡ್ಕೋಬೇಡ್ರಿ, 100% ಆಗಿ ಮುಗಿಸ್ಕೊಡ್ತೀನಿ ನಾನು. ಬಟ್ ಐಲ್ ಟೇಕ್ ದ ಮೋರ್ ಟೈಮ್, ಸ್ವಲ್ಪ ಟೈಮ್ ತಗೋತೀನಿ, ಬೇರೆ ಬೇರೆ ವರ್ಕ್ ಇದೆ. ಈವನ್ ಐಲ್ ಬಿ ಕಾನ್ಸಂಟ್ರೇಟಿಂಗ್ ಆನ್ ಯುವರ್ ಕಮ್ ದಿಸ್ ಫ್ರೆಂಡ್ಸ್, ಯು ಕಮ್ ಹಿಯರ್, ಬಾ ಸುಪ್ರಿಯಾ, ಕಮ್ ಹಿಯರ್. ನಾನು ನೋಟ್ಸ್ ಬರಿತಾ ಇದ್ದೀನಿ, ಎಷ್ಟಾಯ್ತು ನೋಡ್ತಾ. And even I'll be giving the solutions to the each and every question paper. Problems also are there, program also there. I will be trying to write each and every programs also in this. Okay, I am making the some notes. I don't have any work. Only one subject is there with me. That's the DSDV. I'll give the 100% solution to this subject. Okay, don't worry. This is very easy language. Okay, this is only one of the easiest subject. ಯಾರಾದರೂ ಪಾಸ್ ಆಗ್ಬೋದು, ಒಂದಿನ ಓದಿನೂ ಪಾಸ್ ಆಗ್ಬೋದು 100%. ಒನ್ ಥಿಂಗ್ ರಿಮೆಂಬರ್. ಬಟ್ ಪಾಸ್ ಆಗ್ಬೋದು, ಸ್ಕೋರ್ ಆಗಬೇಕಾಗಿದ್ರೆ ಕ್ಲಾಸಸ್ ಬರ್ರಿ, 4 ಇಲ್ಲ 5 ಮಾಡ್ಯೂಲ್ ಕರೆಕ್ಟಾಗಿ ಹೋದ್ರಿ ಸ್ಕೋರ್ ಆಗುತ್ತಾ, ಮೋರ್ ದೆನ್ 80 ಮಾರ್ಕ್ಸ್ನು ಸಿಗ್ತಾವೆ ಇದ್ರಾಗ. ಫಂಕ್ಷನ್ ಇತ್ತು ಅನ್ಸುತ್ತಾ, ಟೈಮ್ ಎಷ್ಟಾಯ್ತು, 12:45. Okay, today is the, I will not be repeating, this is the 4th time, same topic I am repeating here 5 times. Okay, ಪೂಜೆಗಾರ ಸಾಕಾಗಿ ಹೋಗ್ಯದ. ಯಾರು ಅಂಕಿತ ಯಾರು ರೀ, 2-3 ಸಲ ಕೂತಿದ್ದಾರೆ. ಭವಾನಿ ಅಂತ ಅನ್ಸುತ್ತೆ, ಭವಾನಿನ 2-3 ಸಲ. ಬಟ್ ಐ ವಿಲ್ ನಾಟ್ ರಿಪೀಟಿಂಗ್ ದಿಸ್ ಒನ್. ಓಕೆ, ಡೆಫಿನೆಟ್ಲಿ ಶೋರ್. ಓಕೆ, ನಾಳೆ I'll not take this one. Okay, definitely I'll go with the syllabus, complete syllabus about the, this is the 100% question. Okay, this one you have to write the practice this one. Okay, 100% question. ಈ ಕ್ವಶನ್ ಪೇಪರ್ ಅಲ್ಲಿ ಕಂಪಲ್ಸರಿ DSDV ಕ್ವಶನ್ ಅದಂದ್ರ ಇದು ಕ್ವಶನ್ ಇರಲೇಬೇಕು. This is what the some compulsory question you should have to practice in the classroom only tomorrow. ಸರ್ ಯಾಕೋ ಕ್ಲಾಸ್ ತಗೋತಿಲ್ಲ ಅವರು, ನಾನು ಮತ್ತೆ ಅನಿವಾರ್ಯಕ್ಕೆ ನಾನು ಬರ್ತಾ ಇದ್ದೀನಿ ಅಷ್ಟೇ, ನನ್ನ ಕ್ಲಾಸ್ ಇರಲಿಲ್ಲ, ಸುಮ್ಮನೆ ಅವ್ರ ಮೀಟಿಂಗ್ HOD ಸರ್ದಿತ್ತು, ಅವ್ರದ್ದೇನು ಮೀಟಿಂಗ್ ಅದ ಅಂದ್ರೆ ಆ ಕಡೆ ಹೋದ್ರೆ, ಇಲ್ಲ ನಾನು ಬರ್ತಿದ್ದಿಲ್ಲ. ಅಟೆಂಡೆನ್ಸ್ ಕಂಪಲ್ಸರಿ, ಮೇನ್ ಅಟೆಂಡೆನ್ಸ್ ಅದ. Okay, one more announcement is there. One announcement is there for the 2nd March for the